instead of the 0b, we're going to have to use a different formula to get to the equation. So we'll come back to this in a sec. Okay. So let's look at those cases when we have a point that is not the y-intercept and a slope. Okay. So again, it still comes back to we need a point and a slope. And if that point is our y-intercept, 0, b, you are good to go. You just plug it right into y equals mx plus b. However, if you are given just some other random point, we'll call it x1, y1, some point that is not the y-intercept, it might even be the x-intercept. Okay? It might be x, 0. Doesn't matter. It's still a random point. It's not going to help us in this case. Okay? So you're given some point and the slope, m. Okay? Then you are going to use y minus y1. There's just a y, plain old y, and then minus your y coordinate is equal to your slope times x minus your x coordinate. And this is called, appropriately enough, the point slope formula. And you might see it written as point slope form. I prefer to call it a formula because we are not going to ever leave our equation in this form. Right? It's used as a formula, and then we have to simplify it to one of our pretty forms. You'll look at the directions, and you either have to put it in slope-intercept form, function notation, or standard form. Point slope formula is just to get us started. Then we have to clean it up. Okay. So, for example, if you have a slope of 3, and a line with that slope also is going through the point 6, 2. So with that information, you can graph the line, you can start to visualize the line. Oh, a slope of 3, positive 3, that's a steep upward line. I know one point it goes through, so I can start to visualize it, I can graph it, but I'm being asked to write the equation for it. Now, all of the forms and formulas that we're using, you do have to have memorized for the test. You're not going to be given them on the test. Okay? Don't wait till the last minute to try and cram and memorize these. I recommend as you're working through these on homework, just write it down every time. Then it's not a matter of memorizing it. It'll become second nature. Okay? So I know I need to write the equation for this. So I write y minus y1 equals m times x minus x1. Do notice about this right here, do notice that there's subtraction in the formula, which means if you are subtracting negative coordinates, that ends up being a plus. Just like in the slope formula, subtraction is important. If the coordinate is negative, then you're doing minus a negative. Okay? So I plug in what I know. Y minus my y1, my y coordinate, is 2. My slope is 3, parenthesis, x minus my x coordinate, which is 6. And then I clean it up. I clean it up in 2 ways. One, if my slope is a fraction, I'm going to kill the fraction first. I'm going to use the same technique I use like when I kill a fraction in a linear equation. Okay? I'm going to wipe it out by multiplying everything by the LCD. How many terms have I got?
3.
1, 2, 3. Right. If I unlock this, I'll have 4 terms. So don't remember, always fractions before parentheses. All right? So I've got 3 terms. I'll multiply everything by the common denominator. Leave this locked up so it's not touched. If this were a fraction. Huh? We'll do an example of that next. Right now, though, the second way you clean it up, now if there's no fractions, so you've killed them, now you distribute. Okay? Make sure you distribute completely. Mind your negatives. Y minus 2 is equal to 3x minus 18. Okay? Now, that is your point slope formula, everything plugged in and cleaned up. But you're not done. What you do now is you go back to the directions and figure out which form you're supposed to put it in. Okay? So next step is to look back at the directions and see, do I need to put it in slope-intercept form, function notation, or standard form? Okay? Now for the first couple of these, I'm going to show that, and then after that, I'm just going to get to this point, but you're always going to have to then you're always going to have to clean it up into one of the forms. Okay? So what that looks like is this. I've plugged it into point slope formula, cleaned it up, killed a fraction if the slope was a fraction, and then distributed. Now, if I am asked to put it into, let's see, yeah, if I'm asked to put it into a slope-intercept form or function notation, all I have to do is solve for y. So I take my cleaned up point slope formula, y minus 2 equals 3x minus 18, and I solve for y. I'm going to add 2 to both sides. And that's it. Yeah. Now, if I had a coefficient on y, which I might if I ended up having to kill fractions, if I had a coefficient on y, then I'd have to divide away the coefficient. Okay. But I don't. That's all I have to do right there. I just solve for y. I push the constant over to the right-hand side. Now, if I wanted if I was asked to put it in function notation, then once I solve for y, I just change the y to be f of x. Okay. Now, you'll never be asked to change them to all three. I'm just doing that as an example in these first couple. And then you need to go back. Like I said, the direction is going to tell you to change it to one of the pretty forms. If you're asked to change it to ax plus by equals c, well, you're not going to have to worry. Remember, these are capital A, B, and capital A, B, and C because these are integers. You can't have fractions in standard form. But no worries. You're not going to have to worry about that because when you kill that fraction, if your slope were a fraction, when you kill it, all your fractions are gone. So you're not going to have to worry about that. All you have to make sure is when you have to put it in this form that your x and your y are on the left and your constants are pushed over to the right. And maybe, in some cases, when your x is negative, when your a is negative, I'm really picky about this, you make sure you have to have a leading positive. So if your ax is negative, you have to change it to positive. And as long as you're fair to the other terms, you multiply or divide every term by -1, it just flips every sign, then that's fine. Okay? So, to put it in standard form, I take my nice cleaned up point slope form, y minus 2 equals 3x minus 18, and I'm going to move my variables to the left and my constants to the right. So I'm going to do minus 3x on both sides to get negative 3x plus y minus 2. Okay. Those are unlike terms, so I just put them in alphabetical order. Negative 3x plus y minus 2 is equal to negative 18. And now I will move my constants over to the right, so plus 2 on both sides, giving me negative 3x plus y is equal to negative 16. Am I done? Right. I want it doesn't matter about the b and the c. What matters is this first one should not be negative in pure standard form. So I'm going to make it positive. Basically, I multiply it by -1. Now that's a fair move if and only if I
multiply everything.
Right. Every term multiplied or divided by -1. It does the same thing. Multiplying or dividing by -1 just flips the sign. So if I make negative 3x positive 3x, this becomes equals positive 16. Okay. So here's your three forms depending on what you're asked. Is that okay? Okay. So this is we have no opportunity sort of for catch-up because our exam is on Tuesday. So I will be sort of barreling through, make sure I cover everything, but do stop and interrupt me with questions if you miss something, okay? All right, so a couple more examples of this. And let's see. All right. So let's look at cases where it's a little messier. It's the same setup, the same arrangement. Your whole point is you need a point and a slope. Okay? But if it looks a little messier with a fraction, this is how you handle it. So if the slope equals 3/2, for example, and it goes through the point -2, -7. Okay. All right. Let me make real clear here, too, what not to do. You cannot, and this is a common mistake I see on a few papers when people get a little confused. Remember, you need a point and a slope, which you have, but what you cannot do is this. Y equals 3/2 x minus 7. Is that my b? Why is it not my b? Yeah, because it's not the y-intercept. If x is not 0, then your y is not your b. Okay? So this would be wrong. Okay? You can only just plug it in like that if this were the point 0, negative 7. B is only b, it's only the y-intercept when it's 0, comma b. So do not do this. This was wrong. Okay? So I have my slope and I have a random point. I'm going to need to use y minus y1 equals m times x minus x1. Now be careful. Remember, this formula has subtraction. Subtraction matters. If you are subtracting a negative coordinate, that changes things. Okay? So plug it in carefully. Y minus y coordinate is negative 7. So it's y minus negative 7. The formula includes subtraction. Equals my slope of 3/2 times x minus my x coordinate is negative 2. So it's x minus negative 2. So that is y plus 7 is equal to 3/2 times x plus 2. Okay. Now, before we put it into one of the pretty forms, we still need to do some cleanup. In this case, we're going to kill the fraction and then distribute. So this is one term right now. Leave this protected and locked up. One term. We're just going to kill that fraction. You're going to do it just like you kill fractions with when you're solving linear equations. You're just fair to every term. You don't have to worry about the common denominator because there's only going to be one denominator, and it is 2. So you're going to multiply all 3 terms by 2. Now you can stretch it out and write it like we do with linear equations. I'm going to show you sort of a little more efficient way that I do this one because I only have one denominator. Okay? And I know one thing is I lock up my numerator, either in parentheses or I circle it, just because I'm not touching my numerator. Okay? And so I'm going to multiply this by 2 over 1, okay, so that the 2's cancel out. And because I have to be fair at every term, I also multiply this times 2 and this times 2. Okay. So times 2 times 2 times 2. This is the fraction one, so it's 2 over 1, and I just reminded myself, don't touch the 3. If your slope is negative, make sure you move that negative up to the numerator. You always want to use a positive LCD. Don't multiply by a negative LCD. Does this make sense? Does this make sense? It's something you've done before, but I'm writing it in a slightly different way. So I don't want that to look confusing. It's a skill you already have, but I'm just being more efficient with the way I write it. So this becomes 2y plus 14 equals 3. I only canceled out the 2's. 3 times x plus 2. And then to finish up the cleanup, it's 2y plus 14 equals 3x plus 6. I distribute completely. Now, if I was going to ask to put it in either y equals mx plus b or function notation, then I take my 2y plus 14 equals 3x plus 6, and I solve for y. Either way, I'm solving for y first. So I do minus 14 on both sides. Okay. I'm pushing the constant over to the right. Minus 14. Now I do have a coefficient of y, so my last step is to divide everything by 2. And you have to be fair to every term. So I did a minus 14 on both sides. Just make sure I note that. Okay. And fair to every term, divide away that coefficient, and I get y equals 3/2 x minus 4. This may end up being a fraction, or don't change it to a decimal or mixed number, just a lowest term fraction or integer. What's my slope?
3/2.
It better be. Yeah. See, this is what the information I was given in the first, so you can do a little quick check. If it didn't match, then something went wrong. Or if you ask for function notation, just change that y to f of x.
Better be.
It better be, right? So that's a little quick check. Little ways you can check as you go along what your expectations are. That's the nice thing about all this graphing and stuff is you can develop expectations the more you practice, so you can really check yourself as you go along instead of just at the end. Okay, so if this was 2y plus 14 equals 3x plus 6. So to change to standard form, I tend to do this in one step. I want to push my variables to the left and my constants to the right. So I'm going to I'm going to do minus 3x on both sides, okay, to cancel it out on the right. And I'm also going to do minus 14 on both sides to move my constant over to the right, to cancel it out on the left and move it to the right. I just did my addition property twice in one step. Okay. So I end up with negative 3x positive plus 2y is equal to negative 8. Exactly the form. Variables on the left in alphabetical order and the constant on the right, just by using my addition property to move things across the equal sign. And then, right, 3x equals positive 8. Flipped every sign, so that's fair. Multiplication property, perfectly fair. The multiplication property that I did there, everything times negative 1, is the same thing, the same property that allowed me to divide every term by 2. Or kill the fractions by multiplying everything by the LCD. That's the same multiplication property. I'm fair to every term. Okay with that? Okay. More example, let's look at it with a negative. So let's say you've got a slope of negative 2/3. And it goes through the point 1, negative 5. Now at this point, I'm not going to keep changing it into other forms. Okay? We're just going to put it into the point slope formula and clean it up. Okay? But remember, you always then, when you get to that point, you always ask which form. You go back to the directions to see which form to put it in. You're not going to have to put it in all three, but you have to put it in the one you're asked to put it in. Huh?
It depends on what you get to work with.
Yes. Well, you're going to always get to this point, and then the directions are going to tell you which one of these three forms to put the final answer in. You don't have to do all three. You just have to go back to the directions to say, okay, how do I have to finish it off?
Okay.
Yeah. So this is how you do all three, but you're only going to ask you to do one for each problem. Okay. So at this point, we're just going to get it to this nice cleaned up part, and then you'll be able to put it in the form to finish it off. Formula. My y-coordinate is negative, so it's y minus negative 5 is equal to, now remember I'm going to have to kill that fraction, and it's a negative, I'm going to have to kill that fraction, it says my slope is a negative fraction. I'm going to go ahead and write it as negative 2 over 3, okay, because I want a positive LCD, so I just push that negative up top so it's out of the way, times x minus 1. So I've got y plus 5 is equal to negative 2 over 3, x minus 1. Okay. So that's with my coordinates properly plugged in with the right signs. Minus a negative 5 was plus 5, but minus 1 is minus 1. And my slope, which is a negative fraction, so I move that negative up front. What's my LCD? 3. So I'm going to go ahead and lock this up to protect it in parentheses or circle it, just so I know it's not touched and that negative is up there too. And multiply it times 3 over 1. And so be fair to all the terms. Let's kill the fractions, 1, 2, 3. 3y plus 15 equals negative 2. That's my new factor in front, that negative 2, because the 3's were canceled out, times x minus 1. Make sure you're very careful. I see a lot of careless mistakes at this point. Distribute completely and make sure you mind your negatives. 3y plus 15 equals negative 2x plus 2. Now, if you take this further, like I said, I'm not going to work all of that out, but the idea is that if you're solving for y, you're going to subtract 15 on both sides, and then divide everything by 3. Okay? So you'll end up with 3y equals negative 2x minus 13, right? Minus 15 on both sides. And then divide everything by 3 will give you y equals negative 2/3. Oh, there's your slope. It better be, right? And then that's divided by 3, that's divided by 3, and this is divided by 3. And just leave it like that. Lowest term fraction. Okay? Sometimes it'll be an ugly b. Okay? Or f of x equals negative 2/3 x minus 13/3. Okay. And if I was putting it in standard form, I'd move that 2x over to the left, which is going to make it a positive 2x plus 3y. And that 15 over to the left was just going to make it a negative 13. And my x is positive, because when I move the negative 2 over to the left, so that's already done without having to flip any signs. Okay. So one of these 3 forms. Okay. But this is how you work it out. The idea is you either solve for y, which means push the constant over and divide by the coefficient of y on every term, or put it in standard form, which means move the x over to the left and the constant over to the right, and then just make sure that x is positive. Is that okay? Okay. 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 So, in all of these cases, you were given a point and a slope. And the point was either that nice, pretty y-intercept or a random point. But either way, a point and a slope. Now we're going to look at some cases where you're given a point and a clue. So, given a point, and that point might be the y-intercept or not, but you're given some point, but instead of being given the slope outright, you're given a clue. Okay. And that clue is to find, it's going to be enough for you to find the slope, which is what you do first. So you find the slope first, given that clue. Okay. So that's why you have to know a variety of ways to find slope, depending on what you're given. Okay. So for example, you are told to write the equation of a line that passes through the points 8, 5, and 5, negative 4. So, you have 2 points, but you don't have a slope. So, first thing you need to do is,
Delta.
yeah,
Delta y.
exactly. You need to find that slope with that change in y over change in x. You're given 2 points. Okay, so subtract the y's over subtract the x. 1. So your 1 is you must find the slope. So we've got, like I said, I go left to right. My y is 5 minus negative 4. And then x is 8 minus 5 on the bottom. Be very careful, because if you get the wrong slope, if you're careless about getting the slope, everything else is going to be wrong. It'll be the wrong equation. Okay? Be real careful up here with this point. So we've got positive 9 over positive 3, or 3. Okay. So I've got a slope of positive 3. Now, does it matter which of these, I've got 2 points, I only need 1. Does it matter which one I use? No. Slope is the same anywhere on a line. It doesn't matter what point you use. So pick one. Sometimes one will obviously look a little simpler than the others, and sometimes it's, but it doesn't matter. Okay? I'm going to choose this one because it has the same signs. Okay? But that doesn't mean it's wrong if you choose this one. You'll get to the same equation. Now I'm going to cross it out, again, not because it's wrong, but because I know my careless mistake is if I have them both to look at, I'm going to end up like mixing up my coordinates. So I cross it out just because I'm going to focus on using this and this. Okay? But that doesn't mean this is wrong. You could have used this one instead. Okay? Just use one or the other. Okay? So 2, we've got one of our points, and the slope we just calculated. Both of my points, both of my coordinates are positive, so it just goes right into y minus 5 equals 3 times x minus 8. If you'd use the other point, it'd be y minus negative 4, or y plus 4, equals 3 times x minus 5. And you're still going to get to the same equation by the time you simplify it. And now you go read the directions and see which form to put it in. Okay, so you try this one. It passes through 4, 0, and negative 4, comma 5. Ooh, do I have a special point there? What do I have?
X-intercept.
The x-intercept, right? So am I going to be able to use it to find my equation? No. It is a special point, but not for finding the equation. You have, yeah, this is not B. There's no B here.
Not
Huh?
special enough.
Yeah, not special enough in this case. Very special in other contexts. Very special. X-intercept is very important. But it's not going to help you. It's not going to help you simplify this equation. You can't use y equals mx plus b because that is not b. But still, you don't have a slope. So if you're like, I need a point and a slope. I got a point, but I don't have a slope. Your first job is I need a point and a slope. So find your slope. Take the clue you're given and find the slope. In this case, the clue is 2 points. So you use your slope formula. So my slope is negative 5 over 8. And then I just choose 1 point. I think I'll choose this one. Doesn't mean this one's wrong. I choose either one. I'm going to cross it out just because I don't want to mix up my coordinates when I'm doing my formula. It's not wrong. It's not bad. You can use it if you want to. 2. Y minus 0. Okay, that's my y coordinate. Equals. Now, right, there's negative 5 on top over 8. Okay, I've got a negative slope. I'm going to push it up to the top there. X minus 4. Now, I'm going to protect that. And what's my LCD? So everything times 8 over 1 here, so it cancels out. And I get 8y, and of course minus 0, so I have to write it, equals negative 5 was protected. I canceled out the 8's. Negative 5 times x minus 4. And careful when you distribute. Negative 5x, positive 20. Now I'm not done. I either have to divide everything by 8 if I'm solving for y or function notation, or I have to move this 5x over to the left. So I'll either end up with y equals negative 5/8. You better, right? Plus, because I'm dividing everything by 8, so 20 divided by 8, which reduces to 5/2, fraction in lowest terms. 20 over 8 is 5/2. F of x equals negative 5/8x plus 5/2. Or I add 5x to both sides. There's no constant to move over in this one. So positive 5x plus 8y equals 20. One of those three will be what you end up with. Does that make sense? I didn't show all the in-between work there, but is that clear what I did? Okay. All right, so go back to that graph from last time, that fourth graph, that corner graph. Huh?
Did they ask for a 2012 form?
Mhm.
Just leave it at 8y equals?
But it won't. Yeah, it never will. That's not something you ever leave it in. It's a means to an end. It'll always be one of these three forms. Okay. So if we look back here, let's find our slope. We're expecting a positive